Hello, everyone. My name is Lou D'Andrea. I'm at Wolfram Research in the user interface department, and today I'll be talking about user interface patterns in Wolfram Language, more talking about things that can go wrong when you're designing interfaces in the Wolfram Language and what to do to set them right. So let's dive in. There's a lot to talk about. First is something that maybe some of you are familiar with. I've covered it before at conferences, but it's worth shining a light on again because this is apparently a thing that needs to be talked about in order for people to get the message. So why does my interface show timed out or aborted? And the reason for this typically is that one is using the wrong interaction with the kernel. So by default, there are two evaluation modes that you can have for dynamic content. I'm displaying examples of them both here. So here we have a while true loop that is saturating the main loop. This is blocking any shift enter evaluations from happening. And yet, if we have an interface, we can interact with that interface. And this is going back to the kernel to get actual new content every time. How is this working? Well, this is working because there's one mode of interaction with the kernel that's optimized for long-running evaluation, and one that's optimized for fast, interactive, possibly evaluations that need to preempt a long-running evaluation. So I'll abort that while true and dig into the nuts and bolts of what's going on here. Essentially, there are two modes, an asynchronous mode and a synchronous mode. The asynchronous mode is the same one that you're familiar with from shift enter all these years. It's a queued evaluation, first in, first out. Can handle evaluations that take days. There's an indication on the cell bracket that things are happening. It can be interrupted, it can be aborted, et cetera, and it doesn't interfere with the front end. And when we built Dynamics, we thought, well, gee, none of those are probably ideal for interfaces. For interfaces, you want something that's very responsive. You don't want the cell bracket flashing. You want it optimized for short evaluations and in such a way that the front end doesn't blink a lot when you're handling these things. To that end, we built a mode where the evaluation automatically aborts after a few seconds. This is implemented with time constrained for those of you that know the language. But choosing which of these interactions to use is key to avoiding aborted and timed out issues with your interface. So by default, Dynamic uses the highly responsive synchronous mode. But if you turn off synchronous updating for Dynamic, you set synchronous updating false, then you'll be able to evaluate things that take longer than a few seconds, and it won't automatically abort. So here's an example of a dynamic which takes too long for the dynamic evaluation timeout, in an artificial way. But in your examples, this might be real code doing real things. There's no way to do 10 seconds worth of computation in a dynamic that's going to time out in 6 seconds. There is, however, a way to tell that dynamic not to use the synchronous updating mode, but to instead use the evaluation queue. And when you do so, the front end reserves a spot for the result. And when that result finally returns, then the front end fills in that spot with the result. So synchronous updating. In other controls, this mode can be accessed via a method option. So in button and a couple of other click handlers, there is these functions take a method option that by default is set to preemptive, but can be set to queued instead in order to use the queued link, the main shift enter link. So here I'm showing an example of a button that has a dynamic label, and then the payload of the button puts up an interface for the user. Whenever you ask the user for content, always use a queued mode or an asynchronous mode, because the user can take as long as they want to interact with this. And they may well, just by adjusting the size and shape of this dialog, overrun the dynamic evaluation timeout until they finally go in here and interact with the thing. So whenever you're asking the user for things, make sure that you're waiting. Whenever you hit the network, if it's a questionable network, or if the network traffic might take, it's non-trivial traffic, it might take a while. Those are the times when you want to make sure to not use the synchronous or preemptive mode, but to use the queued or asynchronous mode. Another common case is when you have a dynamic module initialization. which is a different kind of payload. So dynamic module, we'll talk about initialization quite a bit in just a minute. But here we have an initialization that takes a while. And by default, initialization also participates in the timeout behavior that I described for other dynamic updates. And so here we have this x equal 1 did not occur, right? This dynamic of x is still showing 0. We didn't get any sort of indication that it didn't occur. It just failed silently. This is not good if you're designing interfaces. So for dynamic module, you can turn that initialization into a thing that uses the queued link. And in this case, we see the cell bracket is lit up. And after 10 seconds, this pause will have expired, and x equals 1. We actually achieve that this time. So watch out for synchronicity issues. Don't be afraid to use the slow mode when you know that things have a chance of timing out. Okay, so moving on. Next pitfall. Why does my interface misbehave when I save it to a notebook and reopen, or when I have multiples of these things on screen? And the point here is to think carefully about what it means for your interface to load. And typically that means that any support code gets loaded, and any state that needs to be refreshed from a file or whatever gets refreshed. Now, there are some nice shortcuts one can take for both these things, which I'll point at in just a second. But first, let me mention that you can use auto-loading features in the Wolfram language. These, there have been auto-loading features in the language for decades. But a more modern way to do this is to use the initialization option, as we just saw for dynamic module. There are other structures that have an initialization option. You may be familiar with dynamic and dynamic wrapper. Those have initialization options. But even cell and notebook in modern versions have initialization options. I think we added this, I don't know, 3 or 4 versions ago. So here I'm going to print a cell which has an initialization of just attaching. It will show an attached cell displaying the current time and date. And that initialization gets run automatically when that cell was printed. So the cell is rendered, the front end says that cell has initialization, it runs the initialization. That's useful. However, I claim that dynamic module really is the best club in your bag for this, and I'm going to support that claim with a couple of things that I'll point out here. One is that it is a scoping construct, and it automatically saves state. These are two important things that your interfaces are almost certainly going to need. By scoping construct, I mean that this dynamic module result, this rectangle on screen, localizes its local variables in such a way that they are unique in your whole session and any future sessions to just this region on screen. And in fact, if I make a copy of this, copy and paste, these two values, these two x's here, which initially look like they have the same value, are different x's. And so they won't cross-pollinate. They won't interfere with one another, which is exactly what you would want for interfaces if you had multiple versions of an interface open at the same time. Surely, if you wanted to use global state, that's easy enough to do. Just don't localize the variable. The other thing to point out here is that dynamic module automatically gives you state storage. So it will, by default, take care of storing the local values of variables for you. So if you interact with something that causes some value to variable value to change, that variable value automatically gets changed in the box structure, which then gets stored in the notebook and will be refreshed when the notebook reopens. So all of that you get for free just by using dynamic module, which I think is pretty important. Dynamic module also has some nice features that let you automatically populate the initialization option. This is save definitions is the name of the option. It's false by default, but it's true, I think, throughout the demonstrations project, we encourage people to use this, which is very convenient for building demonstrations. But for when you want to be careful about what's getting initialized, save definitions, you can often find things that it saves that just are a little bit, it's a little heavy-handed. it tries to err on the side of slurping in too much. So be careful when you use save definitions. I did want, however, to point out something relatively new. I think in the last couple of versions, we have added 2 new options to dynamic module. So alongside save definitions, there are now options included contexts and excluded contexts, which allow you to hint the behavior of save definitions. I won't go into exactly how that's done, but they're fully documented symbols. I encourage people who are interested to go and read about them. But it's a nice way to sort of limit what save definitions can do when you need to. And then we've already talked a bit about initialization, and I'd like to talk a little bit more about that and about progress indication. So, pitfall, why doesn't the user know what's happening? Well, it's because the interface developer may have been a bit haphazard when putting things together. So think carefully about what happens when you're initializing, especially what happens when you have multiple copies of this interface on screen and they all want to initialize. Each one, when it appears, is running the initialization. So be mindful of that. Don't use get, use needs so that you're not loading packages more than once. Don't rely on global state. Don't change global state because then you interact with one interface and all of the other interfaces change, which possibly that's what you want, but more likely it's not. And what other levers does dynamic module offer? Well, we talked about asynchronous initialization. We talked about synchronous dynamics. And one of the nice things about these 2 interactions is they can interact nicely with one another. So here we have a dynamic module, an example that will display a dynamic content and that has some initialization that's going to be run asynchronously. All this initialization does is it loads something. Actually, this is just a no-op. This symbol doesn't actually exist. So this pause of 2 is the stand-in for do something that takes a little bit of time, and then let the parent dynamic module know that the initialization has been done. This dynamic can respond to the state of that symbol, and it will know if the initialization has been done or not. And so if I evaluate this, we see that initially it displays in the state that lets the user know, well, we're not quite ready for you to interact with us yet. I'm going to evaluate that again so you can see it again, not ready. And then after, when the initialization is complete, then this is ready. This might, in practice, this might be disabling controls. It might be displaying some sort of please wait indication like I've done here. And in fact, the please wait indication, I mean, this is about as simple as you can get. But this is Mathematica. You can do things arbitrarily complicated and arbitrarily beautiful. Here is something that's not much more beautiful, but maybe slightly more beautiful. Same exact code as before, except the not ready state is replaced by something that has something that's animating. So we have this, some indication to the user that that their lizard brain will accept as, okay, I need to wait for this thing to complete. Fine. And there's other appearances for progress indicator. You see another one in the section heading here. But it's fully documented. Go learn about it and use it. By the way, this interaction between synchronous dynamics and asynchronous initializations is exactly how we implemented the please wait indicator that automatically appears in manipulate when you have a long-running asynchronous initialization. I'll evaluate that again so you can see it gives a state where manipulate knows that it's not quite ready. Also notice that the value of x didn't, the value of x changes at the end of that. So this is something that we learned by dog fooding, and I wanted to shine a light on it, so hopefully other people can make use of it as well. There's lots more that could be said about progress indication and dynamic module. I have a link here to a previous talk I gave on the subject. And this is one of 4 principles illuminated in that talk. I'd encourage you to go check that out. It's still very relevant today. Okay, so that was more about coding. The first half of this talk was about coding. The second half is going to be more about principles that I try to satisfy when I'm designing interfaces. And one such principle is that the screen belongs to the user. And things on screen, you shouldn't mess around with things on screen unless the user has sort of given your interface permission to do so. That includes just having things selected. You shouldn't change the selection. If this text became unselected spontaneously for some reason unrelated to editing this text, that's a problem. Not a huge problem, a minor problem, but it's a good principle to leave selections alone. So that's what I'd like to talk about in this slide. In particular, it used to be the case that selection move was the only game in town when it came to taking care of various front-end and notebook programming operations. But there's often in the modern world better ways to do things than selection move. So here is an example of, let's see, this is a table of buttons, each of which when clicked, will select the button, that button, and overwrite it with some new box structure. So here we have a bunch of buttons, and if I click this one, that one gets overwritten, that one gets overwritten. Okay, that's fine, that works well, but if the user is editing, they have some selection, and then you interact with this interface, notice that it has hijacked the selection. The selection has changed. That blue highlight is gone. Sometimes that's important to avoid. And to avoid it in this particular case, I will point out that the evaluation box that we used to do the selection move before can be used as a direct target in Notebook Write. And when you target this in Notebook Write, Notebook Write can replace this box without changing the selection. So here is the same table of buttons, but whose action function is simpler. And notice that that Notebook Write remains highlighted even as I'm interacting with these buttons. Seems like a minor thing, but I definitely have gotten complaints from people for whom I have some set of control equal interfaces, and I'm editing somewhere else, and they're going through and say, oh, I don't want that control equal. I want to accept that one and accept that one. And notice that the selection hasn't changed. So this is these are things to think about when you're building interfaces. As far as iconize goes, there are sometimes reasons to manage the selection more carefully. So those of you who may or may not know about iconize, there's a way to, let's see how I do this. Multi-click. It's a way to convert an expression to a different view of the expression. Evaluates the same but looks different. Notice that the selection, that this iconized bit is selected, and that's because, well, in part because it's very common to want to toggle iconized selection back and forth via its keyboard shortcuts, which on Mac is Control, Command, single quote. So if I type that, notice that the selection has expanded back to the original expression. And so because we're managing the selection, we can toggle this thing back and forth. This is also the reason why the uniconized button and the iconize lozenge causes the selection to move, because you're now in a mode where maybe you want to toggle this thing back and forth. Okay, so think about selection when you're building interfaces is the bottom line here. I mentioned a bit about box objects. There are going to be a couple of sections in this notebook that I won't open that are labeled as bonus. Those are sections for you to work through on your own. This bonus section talks about a way to build custom targets, and it uses some box reference idioms in order to do that. If you're curious about other targeting ways, other ways to target, I encourage you to take a look at that. But for now, let's move on. So very common to get complaints about alignment in interfaces. And usually, often, maybe not usually, often, those things can be handled by knowing about the alignment option, which perhaps you know about from graphics or grid. It lets you say where an object should be when there's sort of rattle room when there's room in the object for that content to rattle around. So here we have a frame around a single character, and that single character is aligned at the top right of the frame. And for grids, we can align on decimal point, fine. We've had this for years. Overlay is a somewhat newer expression, and this example points out that when we have a multi-headed thing like overlay, we can use item wrapped around the individual things in order to align them differently from the overall alignment in the overlay. So we have, A being aligned by the default location, B is aligned at the center of the right edge, and C is aligned at the center of the bottom edge. Okay, so that's fine, still using alignment. However, there are some more interesting things to say about the alignment of expressions. And that is when you start thinking about baselines. So the baseline of a font character, those of you who know about typography, you'll be aware, the baseline of a character is essentially the bottom of the character, excluding any descenders, anything that goes below the baseline, like Y, G, J, etc. So this gray line here sort of represents the baseline, and the other colored lines represent other typographically interesting lines. But the thing about baselines is that even non-font objects in Wolfram Language have baselines, and they need to be aligned with their surroundings somehow. So every object, manipulate, entities, quantities, whatever, they all have baselines, and they all can be changed in certain ways. So here is, I've built an academic example that hopefully will be somewhat interesting. Oh, I thought I fixed that. Let's get rid of C. So here we have a list that starts with X and ends with X. So you can draw an imaginary line from X to X. That's the bottom of that X is the baseline of this expression. And then we have a tab view and a grid and a column. Each of those, by the way, has an X in them, but the X's don't align on the baseline. But they could, because tab view, grid, column have the ability to adjust where they align with their surroundings. In fact, here's some more objects that have a baseline position option. There are more than this, but I wanted to give links to at least some of them. And in tab view, you can say I want the baseline position to be the baseline of the currently displayed pane. And in grid, you can say, well, grid is a little bit more complicated because there's various indexed elements here, and you can specify a particular indexed element. Say that I want the baseline of the grid to match the baseline of the element at position 2 of the grid, the second row, second column of the grid, which in this case is the X. In column, there's only one index, 1, 2, 3, so the baseline position of the first element. And sure enough, if we evaluate this, we see that tab view aligns on the X, so all of the X's now are on the baseline, which, kind of interesting. This is much more common to see in sort of frames and panels that you want the payload to be, the text inside of the object to be aligned with the surroundings. This is very common. I want to point out though that if you have nested typeset objects, so say you have a column inside of a grid, inside of a tab view, and it's something in the column that you're aligning by. So in fact, that's the expression that I built up here, a column inside a grid. So here's the column inside the grid, inside the tab view. That column has an X. If we want that X to align with the surroundings, well, we need to work all the way from the inside out. So the column is going to align, well, X is now in position 3 of the column, so we align that at position 3. Grid, the baseline position of the grid is still the position of the element at 2, 2, namely the column, so 2, 2, and the tab view is still the position of the tab view as a whole. And so now we get the X aligning with the surroundings. Right. So baseline position, often overlooked, but very useful. And I wanted to point out this, I think, is a clever example of a pane selector. Oh, I left the answer in here accidentally. Okay, skip back 10 seconds. So here's an example of a pane selector who's, we're cycling through these panes one at a time. And they're moving to the appropriate place where they should be. That's fine. But notice that the cell label is also moving. And that's not so okay. The cell label moving in that way is quite distracting. And gee, wouldn't it be nice if the cell label were to stop moving? Well, the way to it's moving because it aligns with the baseline position of the content of the cell. And in this case, the baseline position of this pane selector is moving to match the currently displayed item. But if you were to nail down, well, maybe I should select the pane selector just to point out that the pane selector isn't changing. It's just the item in the pane selector. So if we set the baseline position of, of the pane selector to be, say, its center, then the cell label will stop moving. So because it's aligned now with the pane selector's baseline position, which is the center. Very nice, very useful. Okay. One more big thing to mention, and then one more little thing. So we're nearly done. I often see interfaces where strings are just not displayed correctly. And maybe it's because they haven't used the right string font. Rarely it's because they're treating strings and boxes incorrectly, and so you might get some truly bizarre spacing, and in traditional form you might even get single letter italics and such. So yeah, use a text font, but even if we do that, well, now there's this big gap here. Well, we can take care of that. There's an option for that. Okay, that's better. But notice that these lines aren't quite filling all the way. So this, there's plenty of room for the to fit here. What's going on? Well, it's because strings live in the math world and using math spacing. And so here now we have sort of text spacing. And maybe you also want to hide the quote characters if this winds up in an input field, an input cell. But there's a better way than to play this game with strings in text, and that is just to use an inline text cell with a named style. So here in one fell swoop, we get a string that displays exactly as text should display using a text font and all the other things that you get from text in an inline cell. And just to drive home the story about baselines, I will mention that inline cells have baselines too. So here's a grid that contains an inline cell that says I want the baseline, and this might be the default for cells, that I want the baseline of this cell to be the baseline of the first line of text in the cell, essentially. So here we have the X's and the first line of text aligning with them. Good. Okay. I wanted to at least give a nod to dark mode. If you're interested, Stephen mentioned dark mode, John Foltz mentioned dark mode, Noah Hardwick earlier today talked quite a bit about dark mode. There's a link to his talk here. I will be happy to chat about dark mode, but I don't think we have time for me to say anything more interesting than what's already been said. But just be aware that dark mode does affect interfaces. Some things you get for free and other things you need to think carefully about. So take a look at these sections and go from there. Okay, well, that covers the things that I wanted to cover. And maybe now I will circle back and take a look at the Q&A. Right. Let's see. This is the front end question. Is it possible to set the default notebook zoom, bottom right hand of the notebook, at least on Windows? That's beyond the scope of this talk. You can specify a global magnification change for every notebook in the preferences pane, the settings pane. But that doesn't change, I don't think that changes the actual widget on the notebook. That would be a different operation. Where can I watch your previous talk, which you referred to? There is a link in this file that links to the Wolfram. It's on YouTube, but I think I found a link to something on the Wolfram site. So take a look at that link and go from there. Let's see, where was that? There it is. Yeah. What's the best way to programmatically use iconize? I'm not quite sure what that means. There is a kernel function called iconize that one can just use directly. Perhaps that's what was meant. But by programmatically, if what you mean by programmatically use iconize is somehow access what the menu command is doing, I could dig out the function that's being called by the menu command that applies to the selection. I don't think that's as useful as just using iconize directly, however. Okay, can you please share your notebook so that we can go through it and digest it more carefully? The notebook is already linked from the talk page on the conference site. And I think with that, oh, did somebody sneak in another? Can we have your contact info or email address? My name is Lou DeAndrea. You can find me at Wolfram Research. Thank you all for your attention and enjoy the rest of the conference.